Hello friends, I'll discuss about flow characteristics and concept of control volume. So in this lecture, so it comes like it's an second half of the first unit, where the first half we would have discussed about the different types of fluid properties. So the second half we're going to discuss about the fluid flow characteristics, so on the concept of control volume. So the introduction about the flow characteristics. Flow may be characterized into many ways, such as turbulent flows, laminar flow, real fluid, ideal flow fluids, reversible flow, irreversible flow, steady flow, unsteady flow, uniform flow, non-uniform flow, rotational and irrotational flows. So before we jump into these different types of flows, we need to understand the broad classification of the fluids. So fluids are mainly classified into fluid static, fluid kinematics, and fluid dynamics. So fluid statics is like the study of fluid at rest. So when it compared to the fluid kinematics, we're gonna discuss about the fluid when it is in motion. So when it is in motion, probably we'll be discussing about the velocity and acceleration alone. We will not consider the force which is being responsible for the motion of the fluid. In dynamics of fluids or fluid dynamics, we'll be discussing about the cause of a fluid flow. So when the fluid needs to flow, it will have some energy, right? So the forces that is being responsible for the movement of fluid will be discussed in a fluid dynamics. So these flows are being studied based on a broad classification of two different methods. So one we call as Lagrangian method and an Eulerian method. So Lagrangian method is a study where a single fluid particle, so fluid is considered of lots of molecules, so single fluid molecules is been taken into consideration, and we're going to study the single fluid particle or a molecule from a start of a flow till the end of a flow. So only one single molecule will be studied throughout the flow. That method is known as Lagrangian method. In Eulerian method, we're going to fix the volume. So we're going to fix the space. So where on the particular space, whenever the fluid moves from one part, whenever the fluid moves inside those control volume, we're going to study about the properties and characteristics of the fluid. So that method is known as Lagrangian method. So probably the Lagrangian method is been, Eulerian method. So that Eulerian method is probably most widely used method to identify the fluid flows and the characteristics. So next jump into the fluid characteristics. As we said, there are different types of flows. These flows we'll discuss in detail by the upcoming lectures. So each and individual flows we'll discuss in detail with a few more practical examples that gives you an eye opening. Right. So next we go with the control volume. So control volume approach is utilized in the derivation of continuity, energy, and the momentum equation. So control volume in the sense we define the volume. So this is a volume. So on this defined volume, what is the mass of flow it enters inside, and what is the flow that exits the surface? It's called as a control surface. So within this region, so whatever the fluid gets in and gets out, we're going to study about the fluid characteristics. That's why we call it as a controlled volume. So probably we've been following the Eulerian method. So based upon this control volume, we're going to derive an equation for continuity, which is an the mass equation of continuity of mass, law of conservation of energy, and law of conservation of momentum. So this equation we're going to derive. So based on this derivation, we will be able to identify the fluid flows. So it's a basic equation for the fluid flows. Right? So next, on a control volume refers to a region in a space and useful in analysis of situation where fluid flow occurs into and out of the space. The boundary of control volume is said to be a control surface. That's why we said. So this is a boundary of control volume. This boundary of control volume is said to be a control surface. So the mass gets into and out of this. We're going to study on this control volume. So at a macroscopic level, fluid consists of molecules with lots of space in between. So if you take a container filled up with some water, or the fluid doesn't mean that it is only a liquid. Okay, so even it might be gaseous also. Fluid is a combination of liquid and a gaseous, right? So the fluid cannot be on a microscopic level, it cannot be bonded, right? So we'll have some free space between the molecules, individual molecules. So but we're going to take into consideration that the fluid is continuous. That is why we call this the uh, concept of continuum. We're going to assume that the molecules are in continuous forms. Okay, so we're not going to take or discuss in detail about individual molecules. We cannot study individual molecules, which is practically difficult. So we're going to take it as on an average, and we're going to study and conclude that the fluid is a continuum. Right. For our analysis, we do not consider the actual conglomeration of a separate molecules. That way we discussed, we cannot consider each and individual separate molecules, but instead we assume that fluid is a continuum. So continuum in the sense it's a continuous, that is a continuous distribution of matter with no empty space. Thank you. This is about the flow characteristics and flow concept of control volume, about the brief introduction. Thank you very much.